Hello, my name is Walter Stone, and I teach math at North Shore Community College. This lesson is about divisibility and prime factors. A prime number is a number that is divisible only by itself and 1. And a composite number is a number that is not prime. So if we think about the numbers that are only divisible by themselves or 1, for example, the number 2, the only factors of 2 are 1 and 2. The only factors of 3 are 1 and 3. So 3 is only divisible by itself and 1. So it's helpful to know the prime numbers up to 30 when we are working with numbers. So the prime numbers up to 30 are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And another thing to notice is that 2 is special because it's the only even prime. So what does it mean for a number to be composite? It means that there is a number that's a factor that isn't 1. Isn't just 1. So for example, 15 is composite because 3 is a factor of 15 and 5 is a factor of 15, and we can multiply 3 by 5 to get 15. So 15 won't be on the list of prime numbers. Also, when we're factoring numbers, it's really great to have some divisibility tests to help us out. So a number is divisible by 2. It means it can be divided by 2 evenly if the last digit is 0, 2, 4, 6, or 8. So a number like 15 is not divisible by 2 because 15 ends in 5. But the number 12 is divisible by 2 because it ends in 2. It's one digit. One's digit is 2. A number is divisible by 3 if the sum of its digits is divisible by 3. So, for example, the number 33. If I add 3 plus 3, the digits, I get 6. And 6 is divisible by 3. So the number 33 is divisible by 3. A number is divisible by 5 if its one's digit is 0 or 5. So if you count by 5s, 5, 10, 15, 20, 25, 30, all those numbers end in 0 or 5, and they're divisible by 5. So these 3 divisibility tests are really helpful when we are looking at numbers and factoring numbers. So here's an example. The number 746, is it divisible by 2, 3, or 5? So if I work with the number 746, is it divisible by 2? Well, I look at the last digit 6. And is 6 either a 0, a 2, a 4, a 6, or an 8? Well, it's a 6. 746 ends in an even number. So what we can say is that 746 is divisible by 2. So we know that 746 is divisible by 2. Okay? So now we want to check for 3. Now, checking for 3 is that sum of digits rule. We want to look and see if I add 7 plus 4 plus 6, is that a number that's divisible by 3? So 7 plus 4 is 11, plus 6 is 17. And 17 isn't divisible by 3. So we would say no in this case. So 746 is not divisible by 3. So 746 is not divisible by 3. And that's okay. The number doesn't have to be divisible by 3. And that's because 17 is not divisible by 3. How about 5? Well, does 746, is that last digit 0 or 5? Well, no. 0 is not the same as 6, and 5 is not the same as 6. So 746 is not divisible by 5. Okay? So we learned that of the 3 numbers we're trying to divide by, 746 is divisible by 2, but it's not divisible by 3 or divisible by 5. Okay? So that helps us when we're trying to factor a number. Okay? So how about 135? Is 135 divisible by 2, 3, or 5? So you try this out, pause the video, and solve the problem, and then I'll come back and I'll see if your solution matches up with my solution. Okay, well, does 135 end in an even number? Well, no. So 5 is not even. So 135 won't be divisible by 2. But it does end in 5. So 135 would be divisible by 5. So we know that 135 is divisible by 5. That number ends in 5. Is it divisible by 3? Well, if I add 1, 3, and 5 together, I get 4 plus 5, which is 9. And 9 is divisible by 3. 9 divided by 3 is 3. So we can say that 135 is divisible by 3. Okay, so we learned that 135 is divisible by 5. And it is divisible by 3, but it's not divisible by 2. It's not an even number. And that's okay. Okay? What is going to be helpful to us in the near future is being able to write a number as a product of prime factors. And there's a theorem called the fundamental theorem of arithmetic that says for any whole number, it can be written uniquely as a product of prime factors. And that makes life a lot very easy for us. So what I want to do is I want to write 48 as a product of prime factors. So I'm looking for factors that are prime, like 2, 3, 5, 7, and so on. And one way to work on this type of problem is to do what's called a factor tree. So if I start off with 48 and I want the prime factors, one thing is I see that 48 is an even number. So 2 is a factor. So I know that if I make a factor tree, 2 is a factor. Now what is 2 multiplied? What number do I multiply to 2 to get 48? Well, 2 goes into 48 24 times. 2 goes into 4 twice. 2 goes into 8 4 times. So 2 times 24 is 48. 24 is also even. So I can take 2 times 12 to make 24. 12 is also even. 12 is 2 times 6. And 6 is also even. 2 times 3. So I can rewrite 48 as 2 times 2 times 2 times 2 times 3. And that's the prime factorization. Okay? Now, what you may be asked to do is write this in exponent form. Well, we have 4 factors of 2, so we can write that as 2 raised to the 4th power times 3. And that's another way to write 48. That's writing 48 as a product of prime factors. Okay? So try this number. Write 63 as a product of prime factors. Pause the video and try the problem and then come back, and we can work on the solution together and match our results. So 63, if I add 6 and 3 together, that's 9. Okay, so I know that 63 is divisible by 3. So what I can say is 3 times what number gives me 63? Well, 3 goes into 63 21 times. Okay? If I add 2 plus 1, I get 3. So I know 3 is a factor of 21. So 3 times 7 is 21. So I can write 63 as 3 squared times 7. I have 2 factors of 3 multiplied by 7. And that's the prime factorization. So being able to work with the divisibility rules with numbers and being able to write a number in terms of its product of prime factors are very powerful things to do when we simplify fractions, and that's coming up next. Okay, so keep practicing, and we will see you soon.